Let's try our second problem. A revolutionary reenactment team demonstrates the firing of a large mortar. The mortar shell is launched with an initial velocity of 45 meters per second at an angle of 30 degrees. If the mortar shell reaches a height of 55 meters, how far will the shell travel? Now, always write your given horizontal and vertical components. Then, since this problem uses initial velocity and a theta, which is 30 degrees, we would have to use 45 sine of 30 to find the vertical initial velocity, and 45 cosine of 30 to find the horizontal initial velocity. Next thing you want to do is always use your kinematics equation. You can either use delta x equals VOT plus 1/2 AT squared, or delta x equals VF plus VO over 2 times t. Now, I would rather use the second one because the first one would involve a quadratic equation, which would make more work. So, using the second one, it would be 50 times 45 sine of 30 horizontal velocity, which plus 0 because VF is always 0 on the horizontal side. So, over 2 times t. Now, doing the math, you would get t equals 4.44 seconds. Now, since this is a problem that involves firing at a certain range where the height is in the middle, you would have the time that it takes to reach this height is half the time it will take to reach the incomplete distance. So the times for the vertical side is half of the time for the horizontal side. Makes perfect sense. So what you want to do the second time is you can now use delta x equals VOT plus 1/2 AT squared, since you find the time by doubling this time, which would be 8.88 seconds, and then plugging it in to find the answer. So since acceleration is always 0 on the horizontal side, delta x equals VOT plus 0, because acceleration is 0, cancels out everything on that side. So plugging in your answers, you will get 45 cosine of 30 times 8.88. which would 45 cosine of 30 would be 38.97 times 8.89, which would equal delta x equals 346.41 meters. Don't forget your SI units because you'll get taken points off. Now, there's another type of problem which is similar to this problem that I first showed you, but that involves, instead of a car driving off a cliff, a projectile shot off of a cliff into the air. These problems are simple as long as you utilize the techniques I have taught you, and you'll be doing fine on the AP test.